seconds and you're live on YouTube. All right, good luck.
Cheers. How do I hang up from you? Hang up. Hey everybody, how are you? Who have we got? Let's have a look. Oh, new people, that's amazing. New people and normal people. It's nice to see you, new people. Some of you have been with me at 12 o'clock today and 3 o'clock today and yesterday and the day before, and we've now been through 50% of the A level. We've been making notes. So for those of you who have missed that, let me grab you a link, just so that if you want to start going through that, then you can. So basically what I'm doing is all over half term, I am doing sessions at 12 o'clock and 3 o'clock and 6 o'clock, and they are going to be focused on revision notes for a particular section of the course. So we've already done half, and it's only what, Tuesday, which is pretty cool. And it's been really nice seeing the numbers actually go up and up this week. Okay, I'm going to stick it in the chat. If you're watching this on YouTube, by the way, it will seem like I'm annoying. I hope I'm not annoying you, ignoring you. But that's because I'm working in Zoom. So if you've got, oh, I did that, send that sort of thing. If you've got a Tailored Tutors login, then you can find it on the live registration page, and then you can click on that and then you can chat to me. So I've got the chat box open in there. So that's where I am. Right, everybody in the room, I have sent you in the chat a link to the live class recording. So you'll see at the top of that, you will see, and even if I share my screen, you will even all see that we have got these sessions that have been going on this week. So this one I forgot to press record. I'll have to do that one again. There's graphs and lines and circles and trigonometry. We've done differentiation, we did today, and we've done these ones here. So for each one, there is a PDF. And basically what we're doing is going through this and filling it in with everything you need to actually know for the exam, so that you've got a set of notes that cover everything. And then these down here, these are all of the content guide videos that correspond to this page of notes. So as we go through, you can highlight the ones of these that you think, actually, I think it would be a good idea for me to go and watch that one, or maybe it makes you realize that there's bits of the scheme you haven't done yet. So hopefully that is going to be of good use to you this week, particularly people using their half-term pass, because we're going to get through the whole lot in this week, in a few days. So today I'm very excited to introduce you to this little baby, which is the new improved maths MID, which we're going to be working on today. And this is going to be a little microcosm of how to use the whole Tailored Tutors universe to cope with the stress of the next 15 weeks. And the way that we're going to reduce the stress is to just take all of the unknown off you, take all of the pressure and all of the sort of feelings of being out of control, take that all away and give you a really, really clear structure which ticks all the boxes for what is a good way to revise. So it's going to be based on, scaffolded around one paper per week. We've got 15 weeks and we've got AS paper 1 and paper 2, A-level paper 1, paper 2, paper 3. So we've got 5 papers per year, and we've got 2017, 2018, 2019. So that's perfect. One this week, one the next week, and so on and so forth. I will give you a link to where this is. It's in, if you're in YouTube, it's in the description. And if you are not in YouTube, then it is, I'll stick it in the chat. Yeah, it's in the, yeah, Hussein's saying it's in the exam guide. It is, but I'll give you a direct link and then you can just click on that. There you go. It's in the chat. So what I'm going to do with you in this session is I'm going to do a sort of mini run through of the TT method so that you can see how the MID sheet works and you can see how the course works, and you can sort of get that understanding of how to use the method. So it's not going to be exactly pure use of the method, because that would involve me sitting with you for about 8 hours. But it's going to give you an idea. So what we do first with the TT method is we do the paper. So it's going to be 1 per week, and you just do it in proper test conditions. Okay, so that's what we're going to do first. We're going to do it in proper test conditions, but we're just going to do one of the questions. Now, when you're doing this method properly, you will do the whole paper in test conditions so that you get used to that stamina of how long you have to go doing complicated maths without starting to make stupid mistakes. But we're just going to do a little microcosm of it for now. Okay, so I am going to, if I can remember how, I'm going to send you a poll. And I want you to tell me which question you want to do. I haven't put all of them in, but I've put a few in, and you can vote for as many as you like. So the options are question 4, which is on factor theorem, question 5, which is on integration, question 6, which is on first principles, question 7, binomial expansion, question 9, trig, question 10, discriminant. So if you're in the Zoom room, you should see that poll on your screen, and I can see people voting now. And a lot of people want to go straight to the A-star questions. I will do that second. How about that? How about second? Okay, let me show you the results. So whilst the A-star question is very popular, and we will do it, and I will explain where I got those from and what they are. Let's start with question 5, integration. Okay. Did you see that? Did you say I wasn't lying? Did that show up? Or you should have seen it on your screen anyway, even, yeah, cool. Okay, so that's good. As long as you know I am actually listening to what you said, not just going, oh, I've made it up. Okay, so question 5, integration. I have got that. If you've got this page open and you're in the exam guide, then you can go to that link that I sent you. If you look just above, I will show you by sharing my screen, then you can just iPad while I'm sharing my screen. There we go. Okay, so this is the page that you're on. This is the link that I sent you. Here's the paper, and up here are all of the questions and the solutions. So we're going to do question 5, integration. So you can just click on that, but I've got them prepared on my screen so that you can see them a bit more clearly, and so that everybody on YouTube can see as well. Okay, so 5, this one, this is your choice. Right, each of these questions that we're going to do today, I'm going to give you 4 minutes. So the stage we're at now is do the paper. So normally for EDEXCEL, this will be 2 hours for paper 1, or for AQA and OCR, your paper 1 would be an hour and a half, but we're not going to do all of that. We're just going to do one question. So I'm going to give you 4 minutes starting now. No cheating. You can't see the link, Cameron. Yeah, if you've got any questions, the timer is on. I'll show you it every so often. Just have an actual proper go at this on a bit of paper. Cameron, let me grab you that link. See if that works. Is that all right? Can you see it? So we're doing this question that's on the screen. If anybody wants to go in the chat and ask me things, then feel free. Cool, excellent. And resist all temptation to cheat here. If you get to the end, if you go relatively fast, then you can use your calculator to check. If you don't know, actually, I say that, normally we could use our calculator to check, but in this case, it tells us that we're meant to be getting 16 plus 3 root 2 anyway. Okay, so it doesn't really matter. But just so that you know, you should be able to use your calculator to type in that integral with the 1 at the bottom and the 2 root 2 at the top and the function, and press go. Now it won't say 16 plus 3 root 2 because your calculator isn't doing algebraic integration. It's doing like a trapezium rule thing. If you're in the second year, you might know what that is. So it's doing an approximation of the area underneath. but it will give you the decimal equivalent. So it means that you can check your answers in the exam. Because as I'm sure you know, mistakes are one of the biggest things that we need to deal with, but we will deal with them. We're going to be using the MID and using the method, and it's going to be covering all bases all the time. It's going to be covering your exam practice. It's going to be covering reducing the number of mistakes you make. It's going to be increasing the productivity of the revision time that you put in. It's going to be giving the most time to the most important questions that come up the most. It's going to be giving the most time to the things that you're struggling with personally, and less time to the ones that you're strong on and that you don't need to work on as hard. So if you haven't got 16 plus 3 root 2, see if you can find your mistake. If you have got 16 plus 3 root 2, just have a look through and check whether you think I would give you all the marks. Okay, do you think I would give you all the marks? Well, not me, like, well, yeah, me, but the examiner. Because this is a show that question. And with a show that question, if you don't hit those method marks, if you don't spell it out what you're doing, you won't get all the marks. Boom. Right, hopefully that was a nice gentle introduction for you. Now, on the link that I sent you, the page that you were on, you can click on number 5, integration. I will show you where it is. And you will be taken to the page that's got the videos on, and I will explain to you what those videos are like. So this stage of the TT method is the second one, where you mark and analyze. Now, normally you will have done an entire paper. So we will be, you would be doing these one at a time through the paper. You wouldn't be doing do a question, mark a question, do a question, mark a question. Okay, but this is just a preview. So this is the page that you were on with your MID, and here is question 5, integration. So you're going to click on that, and then that's going to take you to a page with 3 videos. Now, the video that you're going to choose to watch, I don't know why I've gone blurry, sorry, it's probably because I did that. Came too close. The video that you are going to choose depends on how you felt about that question. So if that question, I don't think anybody's going to be like this. If this question, you literally did not know what to do. I've gone really blurry again. Oh, I know why. It's because I did my phone, isn't it? Sorry. If I hold my phone up like that, then it changes the focus, and you have to do that to make it work again. If you didn't get the question at all, if you thought, I don't even know what any of those symbols mean, then this first video is for you, how to solve it. And what we do in that video is talk through the methods that are needed to solve the question, but I don't actually do the question for you. So what that enables you to do is to get the idea and the tips and the method, but then have a go at it yourself. Because if you just look at the mark scheme, or you look at a video of somebody doing it, that question's ruined, because then you've seen it. So you can't test whether or not you understand. You can't push yourself a bit. So this video is the one to watch if you didn't know what to do. If you did know what to do, then go to the 3rd video, the mark allocation. That's going to tell you exactly where those marks are going to be given to you in that question. If your solution is slightly wrong and you want to compare it with mine, then the best one to watch is the silent solutions. If you're interested in the actual maths and the steps and the thinking and the rhythm of the solution and the structure of the solution, then you go to the silent solutions video. Now, there's a reason they're silent. It may seem silly, and I will click on this one so that you can see, because it's silent anyway, so it doesn't matter that you can't hear it. And there's a reason that they're silent. It's so that your brain can narrate while you're watching. So here's what your brain is doing. Okay, yeah, integrating, written 12x to the minus 2 instead of that. increase the power, divide, increase the power, divide, increase the power, divide. That makes sense. The limits go on the right-hand side. All of this is happening in your head, okay? So you're watching and you're thinking what's happening. And that's reinforcing these methods, reinforcing them, okay? So the silent solution can be the perfect tool for you to embed your understanding of the structure of the solution, to reinforce all those methods in your head as you're doing it, as you're thinking, as you're watching. It's joining up the dots in your head. Whereas if I'd recorded this and talked over it, then you would either be listening or you would be thinking. And it's not the thinking that the brain chooses to do. It goes into just listening. And then you get bamboozled by the speed of the writing and the speaking, and it's too much cognitively, and it's kind of a waste of your time. And the whole point of this method is to make the absolute most of the time available. So a couple of people have already realized what I've done wrong. I thought it was 12, so it was 12 over x squared, and realized that what went wrong is that they wrote 12x squared. So this perfectly, thank you to the people who introduced that into the chat, because otherwise I would have had to make some up. Is anybody else willing to admit anything that went wrong here? Anything that they lost marks for? Obviously, I didn't talk you through the mark scheme, but I've given you the link to it. So you could choose to watch that one and click on that, mute me for a minute and listen to where the marks are basically going, okay? So next, what do we do next in the TT method? So we've done the whole paper. Obviously we haven't, but we're pretending. Done the whole paper. If that was me, I'd put a really shiny sticker there, but you can just put a tick if you want. Now we're going to mark and analyze. Now we've just done the marking. Hopefully you've clicked on the mark scheme and had a look at the mark scheme, and it goes through in detail how to allocate those marks. The analyze is what we write on our sheet. So here's question 5, integration. How many marks did you lose? Don't think about how many marks you got. Think about how many marks you lost. How many marks did you drop, marks I dropped, for something that made you think, oh my God, that is so stupid. I cannot believe I did that. That's ridiculous. So maybe you wrote 12 over x squared is 12x squared. And now when you're looking at that, you're thinking, no, I can't believe it. Or maybe you're not. Maybe you're thinking, why isn't it that? Why isn't 12 over x squared 12x squared? So it's down to you and how you feel and how you respond when you look at the mark scheme. So let's say we lost a mark here, 1 mark for not doing something like that. Actually, you'd lose a lot more, wouldn't you? Because that slip would cost probably 3 accuracy marks, probably a method and 2 accuracies. Okay. People in the chat in the Zoom room, don't forget that most of you have got on all panelists rather than panelists and attendees. So you're like talking to me and then some of you are replying to each other, but you can't see it. So if you set it to panelists and attendees, everyone can see. And if you set it to just panelists, then only I can see. Okay, so let's say you had no clue how to do that at all. Then what you're going to do is you can watch that how to solve it video, and then you can click on this guy here. And this guy here, when you click on it, is going to take you into the content guide, and there will be a video on how to do definite integration, and there'll be an easy, a medium, and a hard question to train you on that particular thing. If on the other hand you why is that moving? If on the other hand, maybe you were losing a mark or 2 here. Now, by the time you get to this stage of the sheet, you'll have done the whole thing. So we'll be looking down all of these to see where the biggest number is. But let's say that was the biggest number there. And that means that that's where our initial focus is going to be. Before we start work on that, first thing we're going to do is our FFS journal. Now, has anybody started an FFS journal yet? So I'm going to start one with you now. Excellent. Some people have. So tell me, what is your journal like? Is it paper? Is it like a Word document? Is it an audio journal, a video journal? Is it on an iPad? What's your FFS journal like? A mini notebook. Nice. I'm going to show you one on here. So this is an app that I really, really like that Rich Warburton, Chemistry Rich, showed me, and I love it. And it's completely free, and you can make these little books. So I thought that we could make an FFS journal for today, and then we can maybe keep going with it and talk about the most common mistakes. So this is what it's called, and it's going to be for frustrating fails and slips, okay? And this is very cool because look, we can change the cover, and what cover do you think? What shall we have? What shall the cover of our FFS be? This one is called, this app is that little thing there. I don't know what it's called. Rich will tell you what it's called because he showed me about it. It's this little wiggly thing. The rainbows, I like the rainbows. I was looking at that earlier. I think like this would be good because it's like, that's what happens when you make a little minus sign slip. And it's like you get sucked into a vortex of no marks for the whole question just because of a minus sign at the beginning. Or maybe it could be this one because it's a storm of annoyance and anger when we make these mistakes. Yeah, the red one is pretty cool as well, isn't it? Anyway, yeah, that looks a lot like mistakes, like just, that's what happens in our brains. That's why our brains write down plus instead of minus. Let's go with that one. So we're going to open up our little journal and we can add some pages to it. You can flick through the pages. Isn't it lovely? I love it. And we will write them down. So the one that we've had so far mentioned is writing this like this. Now, the idea of this journal is not that just we write that down. The idea is that we make such a big deal out of this happening that it will never happen again. So you can do that in lots of different ways. You could write a whole essay to yourself about how bad it was, how many marks it cost you because of doing this, or like you could write yourself a little poster of things like, why isn't that true? We could say like, what's the rule? The rule is that x to the a over x to the b is x to the a minus b. So 1 over x to the b would be x to the minus b. And what we've got here is 12 over x squared, which is 12 over 1 times 1 over x squared. So that's 12 x to the minus 2. But don't just write it down. Not applying the correct signs when subtracting the integrals. That's a really common one. I think the FFS journal should be prettier than this. But when you're doing the limits, it's a really, really common mistake to not control the brackets at that stage. And this minus sign here, that one, that like messes itself up with some stuff going on in here, and that gets really messed up, and then that's why it goes wrong. So all these little things, but do it a lot nicer. No, you definitely, if you differentiate ln x squared, you get 1, and first years don't worry about this, this is second years. If you integrate ln x, if you differentiate ln x squared, you get 1 over x squared times 2x, which is 2x over x squared, which is 2 over x. And what you were trying to do was to find out what would give this. That's a first year thing, that's AS. You have to write it as 12x to the minus 2, and then you can increase the power and then divide, okay? So this, what I've just done there is a really good demonstration of what not to do with your FFS journal. Try to make posters even and write out exactly what you did and annotate it, and just make as big a deal as you can of your mistakes, and then you're going to build those up, and because you're giving such attention to it, it's not going to happen again. Okay. So we have done doing the paper, marked and analysed, thought about whether the marks you lost are for silly mistakes or because you didn't know what to do or because you need more exam practice. If you didn't know what to do, we've done our FFS journal. So that's this column all dealt with now. That's fine. We can move on and forgive ourselves for what we did. You find the biggest number down here. So the place where you lost the most marks out of this whole thing, you find it. And then you decide whether or not to go back and watch the video on that because actually you didn't know how to do it, or whether or not what we just need is more practice. So for the purposes of today, I think what we'll go with is more practice rather than learning, because I'm sure you all know how to do it. So what I've found for you here is a similar question to try. Not exactly the same, but similar enough that it's going to give you the same skills and it's going to help you to develop your skills with that question. So should we give this one a go? Similar question. Yeah? Let's try that one. So for those of you who have got the page open, you can just click on try similar. I will show you where that is going to take us, if I can do this right. Okay, so where are you? You're in this paper here. And we are going to do a similar one. But obviously, this is the whole point of the MID sheet, is that it's tailored to what happens when you do it. So you're only going to be clicking on this question if this is one of the ones that is the biggest number, and that's where you lost the most marks. So that's where you need to put your attention. Okay, right. We have, try not to look at the answer at the bottom, we have got a similar question. Look how similar it is. I have made you really clever links here. I'm quite proud of myself. So that the thing that might have caused the problem, like the 12 over x squared, is then linked back in the next thing so you can give it a go. Right, are you ready to do this properly this time? 4 minutes, grab a piece of paper and give it a go. And if you've got any general questions, then put them in the chat on the Zoom. I know it is Ruhab. Ruhab's saying that the answer's at the bottom. I know, you'll just have to not look. I think I might be able to pull it up there. Is it still on the bottom? There you go then. Get pen. Ruhab, get pen and paper, or pencil and paper, or iPad, and have a go at this question and see if you can do it. See if you can get it right. Okay. I'll keep the timer on there. Yeah, you should be able to do A and B. The number of marks is the number of minutes. So it's a 5 marker, but in the exam, you're doing a lot more checking and thinking and that kind of thing. So I've only given you 4 minutes for this one. So this is the sort of thing that you would do as part of your action hours. You would identify which question had the most, the biggest loss of marks. And then you're going to do at most 3 action hours. So an action hour, you're going to put a timer on for 45 minutes. And when that timer goes, you are going to stop. So one of the really nice things about this plan, about the MID sheet, about the TT method is that it's time-based, not activity-based. So a lot of the study plans that we make will say Tuesday, chapter 1, Wednesday, chapter 2. And then on Tuesday, we only get a 10th of the way through chapter 1, and that's the entire plan out the window, and it feels horrible. Whereas what we're doing with this plan is we're saying, I'm going to do 1, 2, or 3 action hours. And an action hour is not a number of questions, it's literally 45 focused minutes. So what you would do is sit down, put a timer on, and you would click that link to take you to the question that's going to most boost your grade by you putting time into it. And if we've done this one and it works out, then we can click on the other one and have a look at that one. I will keep quiet for a minute and let you finish off this question. If you have finished it, she says, and then doesn't keep quiet. If you have finished it, see if you can think of a way of checking part B, checking your answer, not by scrolling down and reading it, but in the exam. How could you check that in the exam? Because there is a way, a really easy way that you could check that in the exam. And then if you have made an FFS error, then you'll know you have, and you'll be able to look for it. And if you haven't, then you'll know that you haven't. And then you won't waste time looking for a mistake that isn't there. Sometimes when we're marking, it's really, it makes me cry. You see a student has done the right solution, and then for some reason they've decided it's wrong, and they've crossed it all out and done it again wrong. And then we can't give the marks for the right solution because it's been all crossed off. So knowing that you're right is really useful in a maths exam, and knowing how to check that you're right. Rohan is saying, should you repeat questions that you already got right? When you do the repeat, we'll come to that. That's the last thing you do almost. You repeat the whole paper. The whole paper. Okay. So when you're working like this and you're doing an action hour and you're clicking on things and having a go and practicing, then you're just practicing. You've got a timer on for 45 minutes and you're just seeing what happens here, okay? So the solution is, there's the little mark there for x to the -2, and the final answer was A is -2. Now, how could we check that in the exam? How do we know that we've got it right? You just type this little guy into your calculator. So it's the integral from 1 to 3, 36 over x squared minus 2x, press equals, see if you get 16. If you get 16, you got it right, cool. If you don't get 16, you didn't get it right. So then you can go and look for your mistakes. But the more that you fill in your FFS journal and the more care and attention you give when you're putting it in your journal, that I promise you within a week, you will start making fewer mistakes. It'll be really great. Okay, let's have a quick look back at our plan and see how we're doing. This is a week's plan, this MID sheet. This is a whole week, and we're just doing it a little bit cheating. So let's pretend that we've done an action hour now, and we've done an hour's work, and in that hour we didn't have to think what to do because we were able to just click on this link. If you click on this, it takes you to a whole load of questions from the old spec on that topic. So that's not one question, that's loads of questions. And then what we've got here, this is going to be our last one on integration, and then we'll try another question. What we've got here that we can do during our action hour, we don't have to stay on integration. We could move on to whatever got the next highest number of marks lost. But say we were continuing with this one and we tried the similar question, we got it right, tried a couple of practice questions from the question pack. What this is you are not going to have time. If you're an EDEXCEL student, I'm using EDEXCEL as the example because that's what the majority of students do. That's the most popular exam board for maths. You are not going to have time to do all 15 AQA papers and all 15 OCR papers, but they have exactly the same specification, word for word, because it was written by the powers that be. And they said that unlike other subjects, because maths is different, unlike other subjects, maths had to all have the same spec. They couldn't write their own specs. So you will see if you line them up that they have the exact same words, and it's because it was set. So pretty much every question on every AQA and OCR paper applies to EDEXCEL. The only ones that don't is the large data set, because AQA and OCR have got their own large data set. But other than that, it is they're all the same, they're all the same topics. So you're missing out on all of these really good practice questions because you're not doing the AQA and the OCR. And similarly, the OCR students are missing out on some really nice meaty questions in the EDEXCEL. So what I've done is to go through the AQA and the OCR and vice versa for the other ones and link them all here, so that you can have a look what they did on that topic in 2017. Now, you're not going to do this for the whole lot. You haven't got time to do this for the whole lot. We're still only working on the ones that we got the highest marks here for. We're still doing our action hours. But maybe we've got a bit more time in our action hour and we think, oh, we'll have a look at that one. Let's have a look and see what. So if you've got this open, you can click on it, that test question. This is a good way of testing yourself. So you've done the work, you realize there was a problem, maybe you've watched the video about it and made some notes, you've tried a similar question, maybe you've had a look at the question pack and had an idea of what sort of questions get asked. This is a good time to say, right, I'm going to test myself now and see if I can actually do this. Okay. So let's have a look. Where is it? Integration. Oops. That's Trav there, who is online in case you want to ask him anything. So, yeah, all of this I hope is making sense, that this is what you would do for up to 3 hours, right? You're not allowed to just keep going forever, up to 3 hours. Well, that is not an integration question. Did I click the wrong thing? That's don't look at it. That'll spoil it for the integration, for the, did I click the wrong one? I think because it moved twice, I clicked the wrong one. Okay, oh, I'm not even showing you my screen. So that's good. You can't even see my screen. I did it wrong, but it's okay because you can't see my screen anyway. Right. Let's go back to our FFS sheet. So we've been doing that, and let's try another one then. Let's do a poll. That's what I was going to do. Right, you tell me, what would you like to do next? So the poll might have appeared behind your browser. So just go find it if it's gone behind there. Trig equation, good. Trig equation is popular. So if you want to vote against trig equation at the moment, that is definitely winning. Trig equation. Anybody else want to put a vote in? Okay, trig equation is definite. Oh, last minute push by first principles, but look, trig equation is definitely the winner. So we will do that next, okay? Close the poll. Now I've forgotten what just won. What just won? Trig equation, the trig equation. Okay, so if you've got your screen open, I'd encourage you to start using these links yourself so that you get used to where all the links are and how to find everything that you want to do in the course. But just in case you haven't got that open, I will do it on this screen. So you're going to go down here and you're going to go to number 9 and you're going to click on trig equation, and it is going to give you this, but don't, oops, that's not right, but don't cheat, don't look at the answers. We're going to do 4 minutes. Where's the trig equation? No, that one. Okay, 4 minutes. If anyone is totally stuck, then feel free to stick a question in the chat on Zoom, because there's no point wasting this time. If you literally have no clue what to do, then I can give you a nudge in the right direction. Or maybe you know what to do to start it, but then it's not working. If you have finished, think about how you can check your answers in the exam. Don't let the exam be the first time you ever try to check answers, because it won't go very well. So instead of looking at the videos, just give yourself a minute and think, how would I check that I've got the right solutions? My arms are tired. The other type of check that you might start doing based on your Ffs journal is answering the question correctly. So in this case, does the question require a particular form of the answer? Does it require exact solutions or 3 significant figures or something like that? And the more that you fill in your Ffs journal with didn't read the question, didn't give the right number of accuracy, didn't give units, didn't write it in the form ax plus by plus c is 0, did write it in the form ax plus by plus c is 0, but a, b, and c weren't integers. All those sorts of things. The more that you write them in, the more aware your brain will be that these things need to be avoided. And the less likely you will be to do those things in the real exam. And therefore, the higher your grade will be. That journal really does make a big difference to the way that your brain approaches doing maths, because you get genuinely annoyed when you start filling it in. I don't really know what you mean, Rohan. Should you repeat exam questions if you've done all of them? What, all of them in the world that have ever been invented ever? No, exactly. You're going to repeat the whole paper at the end of the paper. That's the only repeating you need to do unless you want to. Maybe if you found a question difficult, then you'll use the traffic light system and make it red. And then maybe one of your action hours will be to do all of your red questions again. Okay, for those of you who haven't checked, try subbing them back in. That's how you check. Okay, so couple of mistakes and things being picked up. So if I go back just briefly to the place where we would be at this stage recording everything, because don't forget we would have done the whole paper and now we would be marking it and going over everything and putting our information on here. So the trig equation, the link is in the same place as it was before, so you can click on number 9 and it will take you to the 3 videos, the how to solve it video and the mark scheme video and the silent solution. So I'm going to let you have a couple of minutes now just to click around and see if it works. Now, I would encourage you, particularly people going for an A star, before you do that, see if you can check them yourself. My big mega calculator is upstairs, but if you have the Casio FX50 or 20, then you can literally type that equation in, the equation that we were looking at. You can literally type it in and it will tell you the answers. Even if you don't have that, you can still get the answers because you can see whether or not yours are right by subbing back in. The things that you might have needed to be careful with here, and maybe you will be writing these in the Ffs Journal in a minute, is that it wanted the answers between 360 and 540, which is unusual. Did you notice that? It wanted 1 decimal place. Did you notice that? Okay, so what do we need to know for this question? We need to know that sine squared x is 1 minus cos squared x. And then fiddle, 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 get a quadratic, solve the quadratic, find out what cos x is. Now, Emma, I think it was you was saying, I've forgotten, like the first one I know how to get, but not the other ones. So I'm going to very, very quickly show you, because I think this will benefit a lot of people, my method for solving trig equations, because it's super duper easy. And I was talking to some students yesterday, I think, when we were doing the trig revision as part of all of the A level this week, and saying that this, for second years, this is such a problem, because in the second year, don't worry about this first years, but in the second year, you write things in the form r cos x, but it probably wouldn't be x, it would be like 3t over pi, r cos x plus a, something like that. And then you have to find out where this is embedded in some function, and you have to find out where that function is maximum or minimum. So you use this nice technique that's in the course where you put something equal to this and this and this, and it's really simple. And then you find out what you need to do. And now you need to solve this equation. And all of that complicated stuff, all of that stuff that teachers have been putting time into with the second years, that harmonic function it's called, that is all out of the window, because what goes wrong is this first year bit, because students can't solve it. So Emma, I will use this as an example, although I realized that, of course, the one that we were doing here was much simpler because it was just cos x is a number that came from the quadratic. Okay, so here's what you do. We would first of all divide both sides by root 29. That's obviously a no-brainer, that's fine. And then we're in this situation. The first step, which isn't needed on that other question, is going to be to write y instead of all of this malarkey nonsense here. So that's going to change the question. It's going to make it much easier. And it means that we only ever solve things that look like this, ever, ever, ever. That's step number 1. Step number 2 is, Emma, the bit that you remembered, which is the bit where you just go shift cos. So, one sec. I've made this question up, so I have no idea what inverse cosine of root 29 is. I've also realized that by putting 3t over pi and 1.03, I've implicitly worked in radians, but first years only know about degrees. So first years, don't worry about the fact that I'm going to be in radians here. It's not the point. The point is the steps that I'm going to do. But I am going to do it in radians. Okay, 1 over the square root of 29. I'm not very good on this calculator. 1.384. Somebody in the chat, in the Zoom chat, tell me why I kept writing. Why didn't I stop at 1.38? For accuracy, yeah, but for what there's the name of the mistake that happens at this stage that people do. Premature rounding, good. This is a massive mistake. It's very tempting to do premature rounding. You're not allowed to round until the end. Say no to premature rounding, okay? Because if you want your final answer down here to be right to 2 decimal places, then you need more than 2 decimal places here. So that's step 2, that's easy. You go shift cos to get solution 1. And the beautiful thing is about this method is that there's only ever 2 solutions. Once you've got those 2, you're basically finished, okay? I can see someone in the Zoom room has raised a hand, but I can't sort of ask you because your mic isn't on. So can you type in the chat instead? So you go shift cos or shift sine or shift tan, done, there's your first solution. Next, you get your second solution, and there's some really simple rules. The second solution, if you did sine, it's going to be 180 minus the first solution. If you did cos, like we just did, it's going to be negative the first solution, or positive, you switch the sign. And if you did tan, it's 180 plus the first solution. Second years, if it's radians, you use pi minus and then pi plus, okay? So then you get your second solution. So our second solution is going to be this guy. Now, you probably don't need that many decimal places, to be completely honest, but I would say do at least 5 or 6. Just make sure you don't lose that accuracy. So number 1 solution, done. Number 2 solution, done. Now what we do is this boring bit, this bit, you just sit there with your calculator and you take your solution number 1 and you add on 360, or second year's 2 pi. And then you add it on again. You just go add 360 equals, and then you write it down. And you build up this big list. These ones all come from solution 1. These ones all come from solution 2. You just literally just go like add 360 equals, write it down. Add 360 equals, write it down. And like you just I usually do like 4, something like that. We can always come back and get more. And you get them by taking 360 off as well. So you've got your original Y1, which was 1.384, you're going to add 360 and minus 360 a few times until you lose the will to live, basically. And you've got minus 1.38, blah, blah, blah there. And you're going to add 360 and minus 360, although really it's 2 pi because I'm doing radians. And you do that for a while. And it's exactly the same method for sine and for tan. The only difference, literally the only difference, is at this stage, how do I get that second solution? The first solution is from shift sine, shift cos, shift tan, and then the second one is either this or this or this. And then we build this big list. And then it is the end. And this is the final thing. And I'm not going to call it step 5. I'm going to call it the final thing, because you have to do this last. You can't do this in between, in sort of whilst doing stage 4. You can't get one of your things, rearrange it back into being T, add 360, rearrange it, but like, and then add it. No. All of the work and the adding 360 and minusing 360s or 2 pi's has to be done before this. Your final thing is you take each of the ones on the list and you rearrange it. So in this case, I would be saying, right, so it's going to be y minus 1.03 and then times by pi and then divided by 3 equals t. So you take each of those y's individually, uncode it back into t and write down what t is. Oh no, this is way better than cast, because number 1, it's algorithmic. So you don't have to do, I mean, what's the hardest thing in maths? It is the things that require you to draw pictures, the graph sketching, the circle geometry questions, the vectors questions, the things that require us to work something out, what something looks like, and normal distribution using the symmetry of the curve. All that is the most difficult bit. And what this method does is totally take that away for you and makes it entirely algorithmic. So just as a reminder, the second solution, if the thing you're doing is sine, the second solution is 180 minus the first solution. If the thing you're doing is cos, the second solution is you just switch the sign. If it was negative, make it positive, and if it was positive, make it negative. And if it was tan, it's 180 plus. If it's in radians, pi minus, minus, pi plus, instead of 180, okay? And then that's it, you've got your two solutions. There's only ever two. All of the others are this one add 360, or this one add 360 twice, or this one minus 360, or this one minus 360 twice, or this one plus 360, or this one minus 360 twice, or blah, blah, blah. And that's what this list is. And then we convert them into t's. And then we take the one we want. We won't want all of them probably. So let's see, what have we learned from this question? Let's have a look at the solutions. What question was this? Trig. There it is. Any questions about that? Stick it in the chat. I've got the chat open, so if you do have questions, feel free to jump in. Okay, here you go. So this is the solution. Again, didn't know what to do, watch the how to solve it. Did know what to do and want to know how many marks you're going to get, watch this one. This is 3 minutes long. And watch this one if you want to see the rhythm of the solution and the way the solution is laid out. I will play this one for you, but it's silent. So you are in the course, hopefully yourself at the moment. This part of the idea of this is to help you to navigate the course. So go to this page and you choose the video that you want. If you are watching this one, remember, you're annotating it yourself. You're voiceovering it. So imagine that you're saying what's happening at each stage. There we go. Any questions on that particular question or how we did it or anything like that? So, sorry, I missed a couple of things. So if you've got the graphical calculator, yeah, you can just get it to solve it for you. But yes, you wouldn't get any method, anything, you get nothing for that. You wouldn't even get 1 mark. And Ricky is saying after the first and second solutions, yep, there are only 2 solutions, only 2. And once you've got the 2, then you just sit there adding 360 on and taking 360 off. And then that is irrelevant. Like those, as I say, I normally do like 3, probably 3, take it off twice and add it on twice or something. And then you are turning all of those back into what they needed to be. So in the case of the one we just did, because it was just an X anyway, the list that I got is the list of answers. And then I just highlighted the ones that were in the range that they wanted. You are allowed a graphical calculator in the exam. Yes, you are. Okay, where's my, oh, yeah. We need to I'm just talking to myself now. Okay, so nice little trig question there. Let's have a look and see what other fun things we've got linked to this that we can have a go at. So you'd watch the mark allocation, or you could just watch the mark, read the mark scheme, it's up to you. But sometimes the mark schemes, I really would recommend that you watch the video, because you might look at the mark scheme and think, oh yeah, I'd get 4 marks, and actually you really wouldn't, because the detail of what we're looking for in the mark scheme. Okay, so that was the trig equation that we just did. The video, Emma and other people who don't know that method, if you click this one, it will take you to the tutorial on that method, like really showing you how to do it, and you can make notes using the template notes as well. Let me just check that works. I did check these links before, but I never quite trust myself that they're all right. Oh yeah, good. So when you go into the content guide, you'll get the video showing you what to do, and then here you will get the notes template. So that means that you can just fill in the notes template while you're watching. So it makes it a little bit easier to make notes. So it just looks like this. Okay, so instead of having to like look up, look down, look up, look down and copy things, you're annotating and you're writing. So you're adding the information. So it just gives you that structure, and it means that a lot more of your brain can be thinking and building networks and building structures rather than just transferring information. Okay. Oh, and then also I should mention there is an easy, a medium and a hard exam question for you to have a go at down there as well. Right. I don't know why I can't go back. Where were we a minute ago? There we were. So that's there if you need it. This is all going to be based on how you get on in that test. Let's have a look at, what would you like to do? Would you like to try a similar question? Would you like to see the whole question pack on trig and choose one of them? Or would you like to see what AQA and OCR had in store for their students in 2017 for trig? What would you prefer? See the question pack, okay? We shall see the question pack. So the question pack is from old spec papers. So this is, what I did was I went through, you can imagine how much fun this was. I went through C1, C2, C3, C4, FP1, FP2, M1, M2, S1 and S2, 4, that's 10 exams for EDEXCEL and AQA and OCR and MEI for 26, what did I do? 2015, 2016, 2017. So for 3 years worth. So million questions, and then just picked out the ones that are most relevant to the new spec. So some of the old spec questions are not relevant at all. Some of them are really relevant. Some of them I had to go and dig about a bit to find because they were on some obscure other paper at some point. But yeah, what you get here is a list of old spec questions so that you know that doing these isn't going to spoil any of the exam papers for you. So you're not doing anything from the new spec, but all of these are just as relevant. The A, the E and the M here tells you how hard they are. So A, apprentice, E, expert, M, master. So M's are the hardest. These are the ones that I've picked out. If you do want to go for an A star, try these 3. Would you like to try one of them? Should we try one of these? And this is all what you'd be doing in your action hours, sort of following these links, making a decision about how confident you're feeling, how much you want to push yourself. Maybe you're feeling tired and you just want to do some gentle practice for a little bit. That's totally fine. Maybe you're feeling really fired up and positive and you want to try something really hard and push yourself. That's also fine. Okay, well, let's go for the EDEXCEL one, since we are looking at an EDEXCEL paper at the moment, but as I say, it really doesn't matter. And I will be prepared to hide the answers quickly, just in case they are visible. They are not. There we go. Oh, nice. Oh, this is a nice question. Good choices, people in the Zoom chat. Right. It's a juicy question for sure. Okay. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes, but I think 9 minutes is going to make us all cry. What's half of 9? 4.5, 5. I think I'm just going to give you 5, okay? And then we'll see where we're at and we can have a look. Yeah, you've changed your mind, Karash, I agree. No, I think this is going to be really fun. 5 minutes, okay? I'll keep holding the thing up every so often, but I'm also going to be writing because I'm going to have a go at it myself. Okay, let's go. Let's do it. Oh, it's in radians. First years, if you, I know a lot of teachers are doing radians in the first year, but if you don't know what that pi there is, I'm just trying to point, but you can't see. The 0 to pi, that's just 0 to 180 is what that's saying. Okay, just 0 to 180, and then the second bit is in degrees anyway. So you could do the first bit in degrees and just go 0 to 180. I'll do it in radians for the second years who are watching. Come on, brain, work. So I'm just going to remind you of those things you do to get the first one, shift tan. Oh, I've given it away that the first one turns into a tan. But the first solution, shift tan. So for those of you struggling a little bit with this, sine over cos is tan. Sine 3 theta over cos 3 theta is tan 3 theta. First solution, shift tan. If it was sine, it would be 180 plus or pi plus. If it was cos, we just switch the sign. If it's tan, we do 180 plus or pi plus. So that gets us our second solution. From there, we just add and subtract 360, or because we're in radians, we add and subtract 2 pi. And we get our big long list of y's. Where are you stuck? Where are you stuck? Like what's happened so far to get you to the stuck bit? It's fine, the root 3 is fine. Move the root 3 cos 3 theta to the other side, divide both sides by cos 3 theta, and then it will say tan 3 theta equals root 3. Oh, I'm not doing very well with getting my bunch of solutions here. I've got my 2 solutions, and now I just need to add on some 2 pi's. I might add on 2 pi again, just for fun. I'll come back if I need more. So r sine x plus a, r cos x plus a, you actually, that is, Cameron, you're massively overcomplicating it, but you are right. So what you're thinking is I've got some sines and some coses. So whenever I've got some sines and some coses equals a number, okay, you don't need double angle formula here, it's a first year question. If you've got some sines and some coses equals a number, you are 100% right. You want to combine those sines and coses into one sine or one cos. So you're doing r sine x plus a or r cos x plus a. In this case, you would choose sine because sine is first, and you would choose minus because it's a minus. So yeah, if that 0 wasn't a 0, you are totally right. You would do r sine x minus a, and then you would divide the r under, and then you would solve it. But in this case, you can just move the root 3 cos 3 theta to the other side, divide under, and get tan 3 theta. This is the thing, what happens a lot of the time with second years is they massively overcomplicate because they've learned almost too much stuff. I still haven't got my solutions. Let me just quickly, how long have I got? 16 seconds. 2 pi. And then, okay, I almost did it. Theta is y over 3, so theta equals, I'll finish it off when I show you. Yeah, exactly. You don't need to worry about that 3 theta is 0 to 3 pi. You're right, yes it is, you're right. But I ever worry about that. I will show you what I mean. So at this stage, because I was chatting, this is as far as I got. I did the first, so move the thing to the other side, divide under, get the tan 3 theta, and then I did step 1 that we were just talking about. Step 2 is shift tan. Step 3, get the second solution, which was pi plus because it's tan. So now I've got my 2 solutions, that one and that one. And then now I did look at the actual range that it wanted. So the range that it was asking for was 0 to pi. So I did have a glance at that and I did think, well, if my theta needs to be between 0 and pi, and I know that what I'm going to be doing down here is dividing all the y's by 3, then I definitely don't want any negative y's. So I did think that, and that's why I didn't do minus 2 pi. I didn't do minus 2 pi and I didn't do minus 2 pi because I knew I didn't want any negatives because I had a look at that. But let's say I did subtract 2 pi. Number one, how hard would it be? Not hard. I'm doing it on a calculator. I'm pressing minus 2 pi equals. So it's no more work and it wouldn't matter. He could just sit here, that guy that I would get by doing minus 2 pi, or this guy, he can just sit there. And now I'm going to divide them all by 3, okay? So dividing by 3 is the same as multiplying the denominator by 3. So I get pi by 9, and I get 7 pi by 9, and I get 13 pi by 9, and I get 4 pi by 9, and I get 10 pi by 9, and 16 pi by 9. And I only want the ones between 0 and pi. So I don't want you, you're too big, and you're too big, and you're too big, and then that's the solutions. Easy peasy. But spending time thinking about how this domain is going to change and therefore trying to only find y's that fit in the new range is a massive waste of time and effort because it's not necessary. It took me half a second, 15 seconds it took me to get them, 15 seconds. Okay. So it's not a big deal. Say you get too many y's, whatever, you got too many, it doesn't matter, just don't use them, it's fine. Okay, let's have a go through part B together. So I'll just jot it down on this page so that you can see it. I need a blank page somewhere, because I think this is a really nice one to go over. It says, given that 4 sine squared x plus cos x equals 4 minus k, and apparently k is between 0 and 3, find cos x in terms of k, and then next, when k is 3, find the values of x in the range 0 to 360. So it's one of those questions that looks like it's really tricky. It looks really unusual, especially as soon as we put a K or a P into a question, it tends to throw students. There was one 2013, 2015, something like that, the EDEXCEL C3 paper. The first page had some P's in it. It had like some trig things and it had P's, and oh, there was an outcry because it wasn't an easy first question because it had letters in and nobody liked it and everyone was very, very cross about it. Okay, but you don't have to do the questions in order, do you? You can do them in whatever order you like. Okay, let's work through this one together. So find cos x in terms of k. Now, first years, we've only got 2 equations. Sine of an angle over cos of the same angle is tan of that angle, and sine squared of an angle plus cos squared of that same angle is 1. Now, we are trying to find cos x, so I definitely do not want that sine squared there. I'm going to deliberately do this wrong to show you the common mistake. I'm finding it hard to even do it wrong. That's the common mistake. It's like riding a bike backwards or something. The common mistake is to not use these brackets and not realize that there's a 4 there as well. That's the common mistake. Okay, so let's go. How are we going to do this? 4 cos squared x. I'm just going to get it all on one side. Minus cos x. It's all going on the right. The 4's cancel. Minus k is 0. So how the hell am I going to do this then? How am I going to find cos x in terms of k? Anybody got any ideas? How am I going to find cos x from this little guy here? Well, he's not a little guy, actually. He's quite complicated. He's got some cos squareds and some coses and things. Oh, it's a good point, Christina's saying, is it not plus k? This is also a common mistake. What I just did was a little bit too cocky, to be honest. What I did was 2 steps in one, and there is no reason to do 2 steps in one, but I just did because I thought I could, and that's why my Ffs journal would be full of things like this. But I don't think I made a mistake in this case. What I did was, instead of moving this 4 over here and this k over here, I didn't want to do that because then this would be negative. So you can think of it 2 ways. You could either think of it that I moved the 4 minus k over and then times through by -1, which I should have done in 2 steps. Or what was happening in my mind was that I was moving everything over to the right. So I wanted that over there. So in my mind, I was moving that over there, and I was moving that over there, and I was moving that over there. And then it would say 0 equals. You're completely right. It's a quadratic. It's a quadratic. I don't think we can factorize it, but we want to solve this quadratic, right? If we can make this say cos x equals, that's done. That's what the question was asking us to do. So we want to solve the quadratic. We've got 3 ways to solve a quadratic. Factorize, which we're not going to be able to do because it's a k on the end and we don't know what k is. 2, complete the square and rearrange. Probably don't want to be doing that, to be honest. Exactly. There you go, quadratic formula. How long is this going to take us? Not very long. Minus b plus or minus the square root of b squared minus 4ac. Be careful with that minus on the k to get the c. Yeah, I bet that goes in some Ffs journals, not realizing that this was a minus, so this is a plus. Oops, that's not how big my fraction needs to be. Over 2a. Another mistake down there is that people write 2 instead of 8 because it's, oh, have I? What have I done? Minus b plus or minus b squared minus 4ac over 2. I don't think I have. No, it's not plus k there. That is not plus k. That's what I was just discussing. Exactly, Hussein, thank you. Right, so here we go. We've now, I mean, you can probably tidy that up a bit, but we've answered the question, find cos x in terms of k. Now, if k is 3, find cos x. So we know that the solutions to this equation, we don't need to go right back to the beginning and put k as 3. We know that the solutions look like this. So all we need to do is go there and sub in the k as 3. So it's going to be 1 plus or minus the square root of something. 1 plus 16 times 3, 49, 7, okay, over 8. So cos x equals 1 plus 7 is 8 over 8 is 1. Oh, that's nice, cos x is 1. And 1 minus 7 is minus 6 over 8. Minus 3/4. Not so nice, but it's fine, we can still do it. And then we're back to the situation we were in before. So I have a question for you. And those of you watching on YouTube, you can discuss amongst yourselves. Those of you in Zoom, put your thoughts in the chat. Why did it say that at the beginning? Was that just for fun? Was that just to throw you, maybe? It's a good question. It was only because of the style of the question. It was this, it said k is 3. It said if k is 3, then solve the equation, basically. If k is 3. But for this bit, k was just k. And then for this bit, k was 3. Yeah, so why why has somebody written that? Because the thing is, these things at the side of equations, mathematicians don't usually write that just for fun. They write it because it's really important, because if you don't write it, there's going to be a major issue. Now, there's only 3 major issues. Second years, if you are doing a question, this is becoming more popular, this question, what is the maximum range of this function? Sorry, not range, domain. What is the biggest domain I could possibly have for this function? So you have to get rid of any that are going to cause a problem. So what's a problem? Problem number 1, there's only 3 problems in maths. Like in the whole world of maths, there's only 3 problems. Dividing by 0, major problem, can't do it. If I make k like 4, yes, Cameron, well done. It's exactly what it is. I'm not telling the YouTube community what you just said. I will in a minute. So if I make k4 here, does that mean I'm going to divide by 0? No, it doesn't. But another problem is doing logs, natural logs or log of any base of something less than or equal to 0. Now, obviously, in this case, if I choose k as 10, I don't end up doing log of a negative, so that's not it. And then the third problem in maths is doing the square root of a negative. And these are our 3 problems that we avoid by changing the domain of the function. So we say not all k's are allowed in. Have a look at that discriminant there. Now, they haven't referenced this in the question at all, but have a look at that discriminant in there. What is that discriminant? 1 minus 16 plus even 16, 1 minus 16k. Is it 1 plus 16k, the discriminant? Did I do that right? Yeah, b squared minus 4ac. Yeah. So I need to have that bigger than 0. My k has to be something that makes that bigger than 0. Has to be. So that means that k has to be bigger than minus 1 over 16. Well, why did they make it between 0 and 3 then? It must have just been for fun. Oh no, I know why it will be that. No, I've thought of something else that can go wrong. This discriminant that was relevant. I do have to have k bigger than minus 1 over 16. Otherwise, if I didn't have that, then I would end up with the totally impossible equation. This entire thing would be impossible because it would end up with a negative discriminant here, and then that's the end of the world because we're trying to square root a negative. But there's something else that could go wrong with this, isn't there? It's not like a major issue like these. These are major issues. This is like the universe imploding type issues. But say we had a different thing in here, and then we went la la la, and we did this thing here, and then we got cos x equals. What can this be? Anything? If I have cos x equals, can it say anything on the other side? And that's totally fine. Would it be completely fine, or would there be an issue? Exactly correct. It has to be between minus 1 and 1. So sometimes when you solve these quadratics that come out of this, you end up with cos x is 3 or cos x is a third. And then you say the cos x is 3 doesn't have any solutions. And by the way, I'm going off at so many tangents here, but by the way, if you do that, if you factorize and you get cos x is 3 as one of the factors, and then the other one you get cos x is a third. If you just look at that cos x is 3 and think, well, that doesn't have any solutions and move on, you'll drop a mark. You need to say cos x equals 3 does not have any solutions because cos is only between minus 1 and 1. And then go solve the cos x is a third. Okay, it's all things like that that you're going to pick up by watching those mark scheme videos rather than just glancing through the mark scheme and seeing that you've got the right answers. Yeah, so that's what's happening here, is that the k's between 0 and 3 are going to produce things between minus 1 and 1, and then it will be things that we can solve, is what they were doing. Unless you have a transformed graph. Oh, yes, sorry, you mean it's not between minus 1 and 1? Yeah, the original cos is between minus 1 and 1, But obviously, yeah, if you shift it about, but then you could rearrange it. Yes, but you're right. I could take the graph of cos x and I could stretch it so that it goes between -6 and 6. And then that would have solutions. Okay, let's go back to the purpose of this, which is training you how to use this method so that you can use it independently of me, other than asking for my help whenever you need it. Okay. We're not doing year 2 topics today, really, although I have strayed into some year 2 stuff because we're basing this week's work. We're doing 1 paper per week, don't forget. So your aim for this week is to do the paper, which is AS 2017 paper 1 for whichever exam board you're doing. Do it in test conditions. Use the videos to watch the mark allocation, maybe watch the silent solution and see how it comes out and see where it is that you differ, and just use it as an exercise. Use it as an exercise in speaking either in your inside voice or with your outside voice, the steps, which is how you're going to learn the procedures, the methods more. Yes, Koresh, I agree with what you're saying there. Right, then you're going to go looking down here and you're going to make your Ffs journal. You're going to make that as important. That's a really important step. Then you're going to do 3 action hours. Each of these is timed 45 minutes, where you go to the biggest number here. You try a similar question, you work on the practice questions, or you try the other question. And you can post questions whenever you want to get some help. I've just made that go squiffy, haven't I? There. And then you're going to do, when that timer goes, 45-minute timer goes, you have to stop whatever you're doing mid-question. It's really frustrating sometimes, but it's dead important. You're going to do that 3 times if you want, but you only have to do once. Then you're going to do an important step. Every step's important, but an important step, which is that you are not allowed to look at any of these exact questions for 24 hours before you repeat the paper. That's really, really important, because what we're trying to do is move the memories slightly out of your short-term memory. So think of it almost like they get put into your short-term memory when you do the paper, or when you go over the question, or when you ask me about it and I explain it. They go into short-term memory and they're sitting there, and then they've got a choice. So your brain is saying, I may never need this information again. I'll just leave it in short-term memory for a bit and we'll see whether or not it's something that I need to remember. If after a week you've never come back to that, it will go, turns out that wasn't relevant, shove it, and it will get rid of it and it's gone. I mean, obviously it will be like stored in the depths of some deep memory thing somewhere, but it's basically gone. The other alternative is that just as your brain, and this is the key moment, this has been proved in lots of studies, that if you want your memory to be as strong as possible, you're trying to catch that exact moment when your brain starts to forget it. And if you can catch it at that exact moment and pull it back by doing the paper again, you form a really strong link in your brain, and that information will be there for you when you need it in the exam. So when you've done your 3 action hours, and you won't have time to do everything, okay? You have to accept that. You have to look down here, and even if there's numbers everywhere, you are going to pick the worst one and work on that first. And then when you feel it's appropriate, you're going to move on in your action hours to maybe the next one. But maybe you'll spend all 3 hours on integration or binomial expansion. Maybe you will. That's okay. Then you make sure that it's been 24 hours before you'd seen it, after you'd seen any of these questions, and then you do the paper again. Now you'll get a lot better, obviously, but you still probably won't do that well. You'll make mistakes on questions that you didn't make mistakes on before. That will be really annoying. You might make the same stupid mistake you made before. That will be really annoying, but it will train you. Maybe you will have done really well on the thing that you've worked on, but there's some other things to work on. And then ideally, you repeat this cycle. You just repeat it round and round, print off a new sheet, do it again. Print off a new sheet, do it again, until you reach your target here. Now, your target is personal, okay? Depends what you're aiming for. It used to be about 83% for an A in maths. It used to be, it's not anymore, it's more like 63, but it used to be about 83. So I would say to students that they had to get 95 if they were aiming for an A, because sometimes it used to be like 90, 92 for an A star. But I would say maybe 10, 15% above the grade you're aiming for. Okay, that's where you're aiming. Because if you can't get 15% more than the grade you want, when you've done the exact questions already, maybe even twice, and you've worked on them, and you've seen the mark scheme, and you've asked teachers questions about it, if you can't get basically 1 or 2 grades above, even in those circumstances, then you are not going to get your target grade. You need to be stretching yourself further, okay? So don't allow yourself to move on. You should be, hopefully, over the course of a week, getting to yourself to the point. You can go through this cycle a few times if you need to, but get yourself to the point where you do that paper, you are crushing it. You're totally fine. You can do all of it. You know it's all fine. 76% for an A star. Yeah, so say yes on the sheet, by the way, on the, where is it? Where did I put it in here? Where did I put the, that, by the way, revision notes is all of the things that we were doing this week. Where did I put the progress chart? Can anyone remind me where I put the progress chart? I don't remember. Anyway. Yes, yeah, absolutely. Okay, let's look at that A star question. I can't remember where I put, but the progress charts, the point I was going to say is the progress charts for you to fill in have got the grade boundaries on, which is the average of the last 2 years. So let's say it was 76% for an A star. In that case, if you want an A star, I would say you don't move on and you don't go and try another paper until you get 90. So 76 to 86 to 90. And if you think that's really hard, you're not going to get an A star. Because if you can't get 90% when you've already done it, seen all the mark scheme, gone over it all again, spent 3 hours working on those exact questions, done the whole paper again, maybe cycled around again, and now it's your 3rd time. If you can't get 90% under those situations, then you're not going to get 75 the very first time you see the questions and you're in a high stress scenario. So by pushing yourself further, you're going to make it more likely that you can achieve that grade that you want. Right. We are coming towards the end of today. So I'm going to do what you said you wanted and talk to you about these A star questions. So if you are going for an A star, what you really need, apart from your Ffs Journal, because you need to be like making really sure that you eliminate those mistakes. If you want an A star, you do not want to be sitting there in the exam just chucking some marks away. But there's another thing you need to be able to do, which is do all the questions, or at least most of them. So what I've done here is to just pick out the hardest 3 questions from the equivalent year of the other boards, so that you know that every week you're pushing yourself a little bit, okay? The other thing to make you aware of, I'm sure you already know this, most of you, but just in case you don't, is that in the exam guide, there is this A Star Academy, 50 hardest exam questions. So this I made when I went through, this is just for 2nd years, but when I was going through all of those old spec papers, I picked out the hardest 50. So they are here. And you've got 15 weeks till the exam. So 15 times 7 is 105 days. It's only 105 days. So if you did one of these every other day, you'd get through them all, okay? But this is all of this. The idea with everything that's on TT is not that you do all of it. The idea is that it is there for you and that you can navigate all of that content in the way that suits you best. So if you're going for an A star, then when you do these papers, you will get that the very first time you do it, you'll get high. And then you want to push yourself in those 3 hours rather than just practicing the same skills over and over. So that is where those things are, if that's you, if you're that A-star student. Okay, let's have a look at this one that we were talking about. Okay, I think it's cool, 100 days, 15 papers, 15 weeks, 1 paper a week. It's cool, it's exciting. You're ready, you're doing fine. If you are still working through content, I would say give yourself a 6-week deadline from this point to finish the content. Talk to your teachers, ask them when they're intending to finish. If they're intending to finish after that, then you take over and learn it yourself, because you want enough time to do this method with the A-level papers. So you need to be getting through that content, ideally in the next 4 weeks, but definitely in the next 6. Okay, so let's have a go at this one here. Okay, so if you've got this open, you can click on that hyperlink. The practice papers are all in the guide. You can click on that, but I have also got it on a page for you because I knew you were going to say you wanted to do it, because you always do in the lessons. There's always this mixture in the chat of simultaneously, let's do A-star questions, they're really hard, let's do them, together with I'm gonna fail, I'm gonna fail, I'm gonna fail. But I like that you're interested in the hard questions. It's cool, it's nice to do. So this is one, this is from AS, it's not from EDEXCEL, that's not true at all. It's from OCR, I think, or AQA, I think it's from OCR, but it's from the same paper is the point. So the MID sheet, the one we're working on this week, is 2017 AS paper 1. So this is from the same year, and this was a question that they had it on it, okay? So it is 1, 2, 3, 4, 5, 6, 7 minutes, but I'm just going to give you 4, and you can have a go, see how you get on with it. The whole thing. You should be able to do the whole thing. I mean, it probably will take you a bit more than 4 minutes, but in the exam, it would take you 7 minutes. Now, those of you who are in the course at the moment, you could, at this stage, if you want, have a play around and have a look at the binomial expansion video. You can get that from the MID sheet, just see where it says binomial and click on that, and that'll take you to the content guide. Or you might want to go and have a look at the binomial distribution in the statistics. It's one of the things I liked about this question, is that it shows you that maths is not just pure or applied. It usually is, it usually is, but this is a really nice way of combining the two, combining the binomial expansion and the binomial coefficients in the binomial expansion, and then linking that up with the binomial distribution. It's not a coincidence that they've got the same name. No, part B isn't crazy. Part C is crazy. Part B is fine. What do you think of that one then? Don't forget that was A star. I've identified that as being difficult. Okay, it's a difficult one, but have a go at it. Push yourself. See if you can. Yeah, part C. I mean, some of these stats questions, they are so difficult to get your head round. The hospital consultant has 7 appointments. Okay, so that's seven trials. So binomial is like you keep doing a trial and then the success or failure. And the number of appointments which start late on a randomly chosen day is L. Right, so L is the number that start late. So success is being late in this case. And the chance of being late is 3/8. And we're going to do 7 days. Show that in this model, the hospital consultant is equally likely to have 2 appointments start late or 3 appointments start late. Okay, so we were talking today actually when we were doing the A-level revision notes, AS and A-level revision notes, we did probability today, and we were talking about the importance in probability questions, all sorts of probability questions, of just writing down how it could happen and writing down the ways in which this thing could happen, because it starts to get your brain moving towards a solution. Okay, so how likely would he be to have 2 appointments? Let's see if we can work that out. That are late. 2 appointments that are late. So how would we work out the chance of him having 2 appointments that are late? No, it's just, I need a blank. 7 3/8. 7 3/8. The probability that L is 2 is equal to 7, choose 2, there's the binomial coefficient. Then we've got 3/8 to the 2, because there's going to be 2 days on which he is late or has late appointments or whatever it was. And then 5/8 to the 5, because if there's 2 days where they're late, then there's 5 days where they wouldn't. Yeah, exactly. Binomial PD with X is 2. The probability that L is 3 is 7, choose 3, 3/8 to the power of 3, 5/8 to the power of whatever 7 minus 3 is, 4. Okay, so what did the question say? That we needed to show that they were the same, that he was equally likely to have 2 late as 3 late. So we'd need to show that those were the same. Would you lose marks for doing it on the calculators? You mean, so if you literally just wrote down equals like that and didn't write this stuff and just wrote a number and then didn't write that and just wrote a number and then said they're the same? Yeah, well, I can tell you. Let's have a look. So the problem with me showing you this is that if I play it, you can't hear it here, okay? But what you would do is you would go to this one and play. That's 3 minutes long. You can even skip forward a bit. I can try to turn it up loads and see if you can hear it.
You need to check how many of these terms you've got correct. So you should have y to the 7, 7xy to the 6, 21x squared y to the 5, and 35x cubed y to the 4. So if you've got 3 of them correct, you can have 1 mark. And if you've got, how many are there altogether? 4. If you've got all 4 correct, you get a 2nd mark. So 2 altogether for that expansion. Right, next we've got method accuracy. The method is for putting these 2 next to each other. Okay, now you can still have the x squared and the y cubed there, that's fine, or not. So actually no, you do need to have them there. Yeah, so you need 21x squared y to the 5 equals 35x cubed y to the 4. And the only other thing you could have basically is this equals this if you got them wrong in part A. So you need to be putting that equal to that third term equal to that fourth term. That's going to get you the method mark. And then the accuracy mark is for getting down to x over y is 3 over 5 by cancelling. Okay, part C. Now, what you need to be doing in part C is finding the probability that L is 2 and the probability that L is 3. But the method mark is for either of those two. So the method mark is literally going to be, what we're looking for is 7 choose some number, and then 3/8 to the power of that number, and 5/8 to the power of 7 minus that number. So that's what you're getting the method mark for. So I would pick it up here, where k is, what am I using there? K is 2, 3/8 to the 2, 5/8 to the 5. Or I pick it up here, because I've got the coefficient, and then I've got 3/8 to the 3 and 5/8 to the 2. But you could have any value of k there, so long as you show that you understand and know that formula. That's the method mark. Then the next method mark is for doing both of them. So for knowing that you need to do the probability that L is 2 and the probability that L is 3, and for working out both of them correctly. And then the explain mark, well, that's what I've done over here, but maybe it's not a very good explanation. You need to show lots of detail, show that you're really manipulating this and not blagging it, basically. So I've got a 21 and a 3 squared, which I've changed to a 7 and a 3 cubed. And I've got a 35 and a 3 cubed and a 5 squared, which I've changed to 7 and 5 to the 5 in order to get these to be exactly the same. But maybe I should even have gone a bit more detail to show that they're the same. And what I definitely need to do is this thing here, therefore they're the same. So this is an explain mark. You need to come up with both of these things and tidy them up to get them looking identical without blagging, and conclude that they are exactly the same to get that explain mark.
Okay, let me turn this down, otherwise I'm going to be shouting at you probably. I'm glad you could hear it. I hope that was a bit helpful. So basically, yeah, Karosh is saying it's safer to write out more method than less. Always, always, always. You're not going to get given 3 marks for just putting something in a calculator and writing equals. Also, it shows that importance of writing therefore this probability equals this probability at the end. So even if you went through and you got that number and got that number and moved on, you're dropping a mark. Yeah, so it's showing the method. If you have a look at the mark scheme, see, you can't see that detail. This is the problem, I think. Students look at the mark scheme and say, so the probability of L is that, and then they'll think, well, I did that on my calculator, so yeah, I got that right, so that's 3 marks. And actually, it's going to be no marks, or maybe 1 mark. There will be notes to the examiners who are working on the paper to say what to do, because it would be a standard thing. We always say, right, if the student does this, because we know what you're going to do wrong. If the student does this, then give them this mark. So we would say, if the student just writes down the probability that L is 2 is this number, and the probability that L is 3 is this number, and doesn't show any working, give them the first mark, but not the other 2, or something like that. But yeah, especially when you're doing a show that, did it say show that? Yeah, look, show that in this model, show that. That tells you that you really do need to be drawing it out. Okay. I think we are about ready to draw this to a close. We normally on a Tuesday do 2 hours, but I wanted to give you some time for questions at the end, and also I wanted to give you a chance before you're too exhausted to, what am I sharing with you? Am I sharing the screen? Can't see what I'm sharing with you. What can you tell me in the chat what you can see? Oh, you can see. That's weird because I can't. Okay, so you can see the iPad basically. Oh, you can see question 10. Right, so you can't see the iPad. That's what I thought. Okay, so I'm going to come back to this and see if it will work. Yay, there we go. So in summary, print this, okay? Or EDEXCEL or AQA and OCR. AQA and OCR, I need to still put in the course, but you'll find it in the same place. I'll put it up for you. And try the TT method Try using it as a way of revising, as a way of studying. So use this paper, do the paper in test conditions. Obviously, you've seen some of the questions now, but that's totally fine. Normally, it's a good idea to do these proper test conditions so you get an idea for where you are. Do your marking and analysing using this sheet. Make your Ffs journal, contribute to it every week, and you can contribute all the time. This thing here, somebody had the link earlier. I'll see if I can grab it again for you, Cameron. The link is A-level papers. There's 2017, 18 and 19 for the A-level papers. Sorry, I'm just going to grab that link for Cameron. Yeah, Hussein had the link. I couldn't remember who had the link. I'll get it now. Are you doing EDEXCEL, Cameron? Otherwise, this is the wrong one. This is the EDEXCEL one. Oh, thanks Hussein. Yeah, so I hope that you have got from this hour and nearly 2 hours, these are the main things I want you to get. Number one, that we strongly recommend that you do paper-based revision, not topic-based revision. I don't think you need to start the A2 papers for another few weeks. So I think we'll do at least 4 weeks of AS. So we'll do AS paper 117, AS paper 217 next week. The week after we'll do 18 paper 1, 18 paper 2. If in that 4 weeks you finish the A-level content, then that's great, we'll move on to the A-level ones. But if you haven't, then we'll just stick with the ASs for a bit. Okay, don't forget your A-level paper is going to be 50% AS. So if you can nail all of the AS, then that is a flipping brilliant start to the number of marks that you're trying to pick up in the exam. So that's one thing, MID sheet, structuring your revision around a paper rather than around a list of topics. And then the next thing is to remind the first and the second years that this week, February half term, I am doing a marathon revision note making sessions, and they are linked in the course. So by the end of this week, we are going to have a full set of notes on the entire A level or the entire AS level, if that's what you're doing. Has anyone got any questions? Because if not, I'm going to go and have some dinner and get ready for tomorrow. What are we doing tomorrow? We're doing, exciting. Tomorrow we are doing integration and then logs and then variable acceleration. That's going to be a big day. That integration one is really important. So Emma, normally the maths lessons are always Tuesday 6 till 8. But this week I'll give you the link to the live class schedule this week, because I know most people are on half term. I know, Ruhab, you're not on half term, but most people are on half term. So we thought this would be a good week to do extras with you. So this is the link for you, putting it in the chat. You said you weren't on half term. Right. So it looks like this. Okay. And these are the ones that we've done. That's the one I forgot to record that I'll do again at some point. And these are the ones that are coming up. So tomorrow is going to be 12, 3 and 6. Okay. And each one is as quick as I can make it. Right. Any questions from anybody before we go have a break? Because I've broken my rule and I haven't done action hours with you. We should have done 45 minutes and then a proper break and then 45 minutes. But never mind. I hope that was helpful for you. And I hope that you feel that you can go forward from this point and do some really well-organized revision that doesn't feel stressful. And you know where I am. If you need any help, you just go on any page at all at the bottom that it says comments, and you can put a comment in and I'll get back to you as soon as I see it. Thank you for coming today. I will look forward to chatting with you in the course and I might see you tomorrow.